So if you want to use that, it's in the extra practice and review section, right at the top of that section, actually. So anyway, all right, here we go. We are ready. We're going to do this review, and we are ready for problem number 9. And I actually just did it last period, so I'm not even going to erase it. When you look at sine x plus 11 pi over 6, what should immediately be your thought?
Alpha plus beta.
Alpha plus beta. This is the sine of alpha plus beta. And what does that formula look like? If alpha is the first angle and beta is the second, then the formula says sine of the first, cosine of the second, plus cosine of the first, sine of the second. So you can see that's what I did right here. Right here on problem 9, right where we left off yesterday. Come on, let's get going. Can't do anything with the sine of x. That's just sine x. But the cosine of 11 pi over 6 is root 3 over 2.
Where are we at? Oh,
On number 9a, on the review sheet that we started yesterday. Can't do anything with the cosine of x, but the sine of 11 pi over 6 is negative 1/2. So this is what you end up with then, root 3 over 2 times the sine and negative 1/2 times the cosine. Whenever you see the sign of an addition or a subtraction, or the cosine of an addition or subtraction, you should immediately think alpha and beta. All right? Now, let's look at example B, or problem B. Secant pi over 2 minus theta. Now, I see that right there, and I'm thinking alpha minus beta, but the problem is, it's a secant. Now, I don't want to memorize any more formulas, okay? I don't want to do that. So what could I do instead? Well, how could I use the knowledge I already have?
Can you just like solve it like a cosine and then at the end flip it?
Exactly. I am going to solve it like a cosine, and then whatever this ends up equaling, I'm going to do 1 over it. Would you agree with that strategy? So what does my cosine formula say? This is alpha and beta. Cosine of the first, cosine of the second, plus, remember the cosines are different, so plus sine of the first, sine of the second. Now you can't do anything with cosine theta, but you can do this. What's the cosine of pi over 2? 0. So this is 0 times cosine, which basically is gone. What's the sine of pi over 2? 1. So this is just sine. So the cosine of pi over 2 minus theta is just sine. Everybody with me? Now that's the cosine of pi over 2 minus theta. I'm supposed to be finding the secant, so I will do 1 over sine, cosecant. Now, just going to take a little bit of an aside here. How many degrees is pi over 2? 90. So would you agree that whatever theta is, pi over 2 is the, or pi over 2 minus it would be the complement of it.
Wait, how much is 1%?
If theta is 50, what's 90 minus 50? 40. That's called the complement of 50. What are complementary angles? Angles that add up to.
Well, why do they have to be complementary?
This is a formula. This is a problem. That's 90 minus theta. So 90 minus theta is always going to be complementary to theta. Now, notice when I did the cosine of 90 minus theta, the cosine of the complement, I got the sine. And when I did the secant of the complement, I got the cosecant. Did you obviously notice we have sine, cosine, secant, cosecant, tangent, cotangent. That CO stands for complementary. The sine and the cosine are complementary functions. In other words, the sine of 40 degrees is equal to the cosine of 50 degrees. Think about your unit circle. Sine 60 is the same as cosine 30, right? That's what that CO stands for, they're complementary. So, they're not the reciprocal pair. Sine and cosine aren't reciprocals, sine and cosine are complementary functions.
Would you say secant and cosecant
Complementary, yeah, and tangent and cotangent are complementary, yep. All right, so in other words, what I'm trying to tell you is, if you can kind of think about that, you could have answered question B without going through all this. When you saw that 90 minus theta or pi over 2 minus theta, that means complement. So, yeah. All right, let's try number 10. It's such a downer when I get so excited and you guys just stare at me. But I'm in the foredrawing.
I thought it was
Thank you, Fred.
I probably would think it was cool if I understood.
All right, here we go. Here we go. Gotta solve the problem. How are we gonna do it? Subtract it over. Either way doesn't really matter. I'll subtract this way. And then what? Factor out a sine. Set it equal to 0, so sine is 0, or secant is 2. Again, I'm just not very good with secants, so if the secant is 2, the cosine must be 1/2. All right, here we go. Where is the sine 0? At 0 and pi. So this one is 0 and pi. If that had been a bracket in the directions, then we would include 2 pi.
Still include 0? Yeah, 0, right? Okay, yeah, I get it.
Where is the cosine 1/2? Would be here and here, right? The cosine's 1/2, that is pi over 3, and quadrant 4/1, which is 5 pi over 3. You all right with that? Oh boy.
Oh, no. Oh, God.
Now we're gonna find out who's got the thinking caps on today. We 100% and subtract this over. And in fact, you're gonna wanna do that because isn't this a quadratic equation? And you gotta have those set equal to 0. But now we have a problem. What's our problem? We got two different variables going on here, right? This is like having x's and y's in the same problem. That just isn't gonna work. Fred?
Would you say that tangent squared is equal to sine squared over cosine squared and secant equal to 1 over?
We absolutely could do that, but we can do something even easier than that, Fred. That will work. I don't want to discourage you. 100% that will work. Olivia?
Tan squared is equal to secant squared minus 1.
Absolutely. When you have a problem that's got tangents and secants in it, then into your head should pop 1 plus tangent squared is secant squared. Now you can't change a plain secant. It has to be squared. This one is squared, so he's changeable. Olivia, what did you say tangent squared is?
Secant squared minus 1.
Exactly. Now our problem is all in terms of secants. Fred, your idea will work, but you're still gonna have two functions, and that's workable, but it's still gonna be, you're gonna have to do something similar, so we'll just do this. So now we have 2 secant squared minus 2 minus 3 secant. So let's get things in the right order, because we're hoping we can factor. If we can't factor, we can use the quadratic formula. Do you think it factors?
Yeah.
How does it factor?
2 and 1 and
2 secant and secant. All right, it is gonna have to be minus 2 plus 1, is that right? Is that okay? All right, so now what? That's equal 0. So now either secant equals negative 1/2 or secant equals 2. I don't do secant, so I'm gonna say cosine equals negative 2 over 1 and cosine equals 1 over 2. So remember, the cosine is just the reciprocal of the secant. Does that make sense to you? What about this? No can do. Sines and cosines cannot be bigger than 1. So we're not gonna get an answer out of that part. What about this? Did I just do that? Where is the cosine 1/2? I think I just did that. Pi over 3 and pi over 3?
Said you did.
So is that all right? Okay, did you catch that little trick there? Where we had to replace tangent squared with something.
Is there a imaginary like it doesn't say 0 to pi, 2 pi?
No, it does. This is all part of problem 10. This is 10. All right, here we go. 10C. Use calculator.
He's dead already. Yeah.
All right.
Keep getting turned on the
So here we go. Why do I need to use a calculator here? Let's see. We have 8
Sure. Yep, I know.
sine squared plus 6 sine plus 1 equal to 0. That's a little quadratic equation. It's got all the same variable in it. Does it factor? It does factor. Into 4 sine and 2 sine.
No, you're good.
plus 1 plus 1. Everybody okay with that? Now you see why we need a calculator? This says sine equals -1/4. Now this one I can do. This one says sine equals -1/2. I can do that one without a calculator because 1/2 is one of my special numbers, but 1/4 is not. Okay, so before you start typing, stop and think about what's happening. You have a negative sign. That is gonna happen down here or down here, would you agree? So the angle we're talking about, whatever that angle is, I gotta make sure I put it in the right quadrant. So if I go to my calculator, and inverse sine 1/4, did you get this angle to be 0.253?
Yep.
Is that what you got? Now, this is all part of problem 10, and as Kellen pointed out, we got these directions. So don't say negative 0.253, don't say positive 0.253, because those aren't the answers. The answers are the 0.253 that is in quadrant 3. Right? We talked about this on your quiz. How do I find that angle? Plus pi plus. So I'm just gonna add pi to that guy, and I got 3.394. So one answer to this one is 3.394. That is the quadrant 3 answer. Now, how do I get the quadrant 4 answer? No. No, doesn't have anything to do with 3 pi over 2. It has to do with 2 pi. 2 pi minus, yep, so 2 pi minus 0.253. 6.030. Oh, yes. It does. All right, now you have a choice. You can do this one, since it's a calculator problem, feel free to do it with a calculator. You could do this one without, and I want to show you how this connects to what you just did. Because I think some of you are still struggling with this, and you've been doing it automatically for forever. So -1/2 is gonna put me here or here, right? What angles have a sine of -1/2? 7 pi over 6. Now, how did you get 7 pi over 6? Well, you know the angle is pi over 6 because that's the angle associated with the sine of 1/2. How did it get to be 7 pi over 6? It's pi plus a 6th, right? And then this one over here, you have no problem telling me that's 11 pi over 6. How did that get to be 11 pi over 6? Well, the angle is pi over 6. So what's that? 2 pi minus pi over 6. Right? You did that in your head, you did this on the calculator. It's exactly the same. All right, we good, okay? Everybody okay with that?
This is confusing now, like, is that, so the one on the left, is that a unit circle?
No,
Okay,
it
that, I was
doesn't
wondering.
need, it doesn't need to be in a circle.
Okay, because that's what I was confusing, like, the X is like bigger than
All right,
the X is like.
all right, here we go. Again, expressions are the same, we have an inequality now, which means our answer isn't gonna look like this. Our answer is gonna look like brackets and parentheses and stuff. We're gonna have shading to do. We have a big problem. Do you see what the problem is? I have a 2x and a regular x. This problem is not factorable. The 2x and a regular x. That has to be dealt with. Any thoughts on that? What? Double angle formula. I have a formula for a 2x. What is it?
2 sine x cosine.
2 sine cosine, that's exactly right. Now, I still am not real excited about the fact that I've got sines and cosines now, but at least it's all x. And I can actually do what at this point? Factor. So I'll pull out a sine, and that will leave me with 2 cosine minus 1. Agreed? Now, somewhere along the line, not necessarily at this very moment, but somewhere along the line, you gotta pause and say, okay, I have multiplied these two things together, and the answer has to be negative. So what does that mean? Big picture now, I'm multiplying these together and I'm ending up with a negative. What does that mean about the things I'm multiplying? One of them's gotta be less than 0 and the other one has to be greater than. And it could be that way, or it could be this way, right? So I've got these two situations I have to consider. Well, this one, if it's gonna be less than, won't it just say sine x is less than 0? And what is this one gonna say about sine x? Sine x has to be bigger than 1/2. This one will say sine is bigger than 0 and sine is less than 1/2.
What about the cosine?
Oh, I keep saying sine, I'm the cosine. Yes, those are cosines, not sines. Those are cosines. Thank you. Yep, those are cosines. Yeah, you can't just magically change things like that. In fact, the only way you can change a sine into a cosine is if it's squared, right? If it's squared, we can do it.
It equals 1, right?
All right, let's see what we've got. Is everybody okay to this point? That we're gonna look at this situation and we're gonna look at this situation. All right, so I'm gonna draw a unit circle. Where is the sign exactly 0? I'm gonna do that with my pink marker. Where is the sign exactly 0? And 0 and pi?
They should be closed dots.
Oh, yeah, that's what we're equal to. Thank you. Any more mistakes I can make here? Let's see. Or equal to, yeah. So that's where the sign is exactly 0. Where is the cosine exactly 1/2? Well, it would be here or here. Is that pi over 3? Or then pi. So here's where the cosine is exactly 1/2. Okay, now for this case, I need to be under my pink dots need to be to the right of my green dots. Would you agree with that? Is there any part of that circle that is pink and green? This little bit right here? So that would be, for this case right here, that would be 5 pi over 3 to 2 pi. Remember, in this case, that dot represents 0. Right? That dot does not represent 2 pi because 2 pi dot's not colored in. It looks like the same point on the circle, but this is 0.
Would 0 still be included? Like,
Um,
would 0 union?
No, where am I gonna put 0? Oh, you mean in terms of an answer, a separate answer? Yes, not in terms of this interval, no.
Yeah.
So, Olivia's point is, alright, so first of all, are we good with this interval right here? Olivia's point is, yeah, but that point is still colored in. Within that domain, that point is still colored in. So we're gonna have to add that x could be 0. Now, I don't know what's gonna happen down here, maybe it'll get included down there, but we're gonna add it right now because that dot is colored in as 0, and 0 fits our domain. All right, now we got to do the second case. All right, so the dots are in the same place. So pi over 3 and 5 pi over 3. And 0 and 5. All right, this time I'm bigger than 0. And I am less than 1/2. We got anything there? Pi over 3 to 5? Both bracketed, keep going. So this is what we end up with as our answer. Now, who has a question about that mess?
For like the final answer, would we like put both of them together, like what situations?
Yeah, this is the final answer. That's the final answer.
Can you just clarify why some of them are bracketed versus parentheses?
If they're included or not.
So like, why is 2 pi not included?
Because in the directions, it says it's not. This is part of problem 10. Go back and look at the direction for
Thank
problem
you.
10.
Okay.
Yeah.
Is there a reason that it's like ordered that way?
What?
Is there a reason that you have it like ordered like 5 pi over 3 to 2 pi at the beginning?
As opposed to what?
As opposed to like 0, then pi over 3 to pi, then 5 pi over 3 to 2 pi.
Is this part of the answer? Was that shaded? The only part of the only part of the circle in case 1 that was both colors is right there.
I was talking about the whole thing for both cases when you write your
Oh,
final.
when I put them
Should we
together?
put them in numerical order?
Oh, it would be great to have them in order. I just put them down in the order we found them.
Okay.
So there's nothing significant about the order. It's great if you put them down in the order that they actually exist. That would be great. But there's no significance to that. All right, we good? All right, now we got some, what should be easy. Let's see. What is the tangent of 3 pi over 4? -1. The tangent of 3 pi over 4 is -1. How do we know that? Because at the pi over 4s, sine and cosine are the same number, right? Sometimes positive or negative, but the same number. And when I put sine over cosine out of pi over 4, it's going to be 1 or negative 1. And in quadrant 2, sine is positive, but cosine's negative, so that's going to be negative 1. All right, how about the next one? The cosecant of 5 pi over 3. I don't do cosecants. I don't do them often enough. I don't do them. So I'm gonna find the sine of 5 pi over 3. Can I do that? You better be able to do that. Owen and Cole. You better be able to find the sine of 5 pi over 3. That's right off your unit circle. What is the sine of 5 pi over 3? Negative root 3 over 2? Right? Which means what is the cosecant then? 2 over negative root 3? You guys don't do the 1 over thing. It's a reciprocal. It's a reciprocal. So if it's a fraction, just flip it. So 2 over negative root 3.
Do we have to rationalize it? No.
And it won't say, if you do, it won't simplify, so you don't have to. Because it doesn't simplify. Sometimes we do because it simplifies. Cotangent, 11 pi over 6. I hardly ever do cotangents. I'm not comfortable with cotangents. So I'm gonna find the tangent of 11 pi over 6. You don't have to do this. This is what I do. Somehow we gotta find the cotangent of 11 pi over 6. What do I know about 11 pi over 6? I know it's down here, right? And that ordered pair, it's a pi over 6. That ordered pair is root 3 over 2 1/2. Negative 1/2. Right? Tangent is y over x. So cotangent is x over y. So what's going to happen when I put root 3 over 2 over negative 1/2? What is that going to end up equaling when I put x over y? So negative root 3 in there. All right, you do the next one with your partner. Secant pi over 3. Tell me what the secant of pi over 3 is. Without your calculator. Enzo, are you thinking? What are you doing, Enzo? Mary Kate?
For the longest time, why would it not be negative 1/2 over
The tangent would be, but the problem's the cotangent.
Oh, so then the
So I just went ahead and
Oh,
said,
so you just went okay.
So the cosine of the angle and then flip it.
Okay, can we get an answer here? 2. 2. The answer's 2. Why is the answer 2? Because the cosine of pi over 3 is 1/2. Right? What in the world about this next one? It's a sine, so that's good news. What in the world? What should we do with this? Break it down, make it find coterminal, get it smaller. So my way of doing this is I just make that a mixed number. So a mixed number for that would be 23 and 5/6 pi. Now, how much of that can I disregard? Not 23, 22 pi. Why do I have to disregard even pies? Because the rotation is 2 pi. So a period is 2 pi. So I'm gonna shrink that down to 1 and 5/6, which is 11 pi over 6. Now be careful, it is negative. So it's negative 11 pi over 6, which puts me where? At pi over 6. And the sine of pi over 6 is? Okay, so let's walk back through that for those of you that got lost somewhere along the way. It's a huge angle, huge. Obviously more than one revolution. So, if I make it a mixed number, I can see exactly how many pies I've got. I've got 23 whole pies, 5/6 of another one. So I took out 22 pies and was left with negative 11/6, 1 and 5/6. So negative means I go this way, and if I go all the way around 11/6, it puts me right here, which is 1/6. And I know that the sine of pi over 6 is 1. All right, you do F. It's the same kind of thing. You do F. Smaller numbers, but the same idea.
This is 4. Is the inverse of 0 just 0?
Do you mean the reciprocal?
Yeah.
No, it's undefined. One of the zeros is undefined.
Okay, well, that's a good question.
Have you done the rest of the homework questions, Rob?
Huh?
Have you done the rest of them yet?
I just finished G4.
All right, what did you do with 11 pi over 3? Turned it into 5 pi over 3, right? And the cosine of 5 pi over 3 is 1/2. Everybody okay with that? All right. What is the cosine of pi over 2? 0. So the secant of pi over 2 is undefined. You think back. One day, I graphed the secant for you, and at pi over 2, there was an asymptote. It's undefined. How about the cosecant of negative pi? I don't know. What's the sine of negative pi? The sine of negative pi, this is negative pi, is 0. So the cosecant will again be undefined. How about the cotangent of 2 pi? Is that undefined also?
Yep.
Cotangent, or I mean, excuse me, 2 pi is right here. Cotangent is x over y, because tangent is y over x. So x over y would again be undefined. Those are all undefined. Okay? All right, let's look at part 12. Notice the notation. In number 12, we are doing the inverse functions. So let us remind ourselves before we get going and write down something crazy, which some of you do in your homework sometimes. Let's refresh our memories. Inverse sine is negative pi over 2 to positive pi over 2. No, that's our range of answers. Okay, any answer you give me has to be between negative pi over 2 and positive pi over 2. That is also the case for the inverse tangent. Now, what about the inverse cosine? That is 0 to pi. Any answer you give me has to be between 0 and pi. Okay? So don't write down an answer unless it fits that right there. All right. So we want to find some angle that has a sine of negative 1/2. Now you should know at this point that if the sine is a half, the angle is pi over 6. Right? But it's a negative 1/2, so it's got to be in quadrant 4. And I know you're thinking 11 pi over 6. No, you can't think that. You have to think an angle, a pi over 6 angle, that's between negative 1/2 and positive 1/2 pi. So what's the answer? Negative pi over 6. Negative pi over 6. What is the angle that has a cosine of 1 over root 2 or root 2 over 2? What is the angle? Pi over 4. And you can say pi over 4 because that's in your space, right? What is the angle that has a tangent of negative 1? Now, I know when you go around your unit circle, you got x's and y's, you've memorized those are sines and cosines. If the tangent is 1, then don't x and y have to be the same number? Right? But one of them's positive and one of them's negative, so that has to be down here. So Enzo hit it on right away. Enzo said negative pi over 4. And he's right. Now the next one says the cosecant is 2 over root 3. That means the sine is root 3 over 2. So let's make sure that's clear with everybody. This literally says, find the angle whose cosecant is 2 over root 3. Well, if the cosecant is 2 over root 3, then the sine has to be root 3 over 2. What angle has a sine, a y, of root 3 over 2? Did you say pi over 3? You were right. Tangent is sine over cosine. So cotangent is cosine over sine. Cosine over sine. So that's like a 1/2 over a root 3 over 2. What kind of angle has an x of 1/2 and a y of root 3 over 2? This is really skills. The answer is pi over 3. Where's the secant 1? Wherever the cosine's 1. Where's the cosine 1? one more, let's graph a tangent. We're not having a quiz Monday, I'm pushing it to the next class, whenever that is. We're gonna spend a little more time with this. All right. All right, here we go, folks. Step one, what are you gonna do? Take out a 4. If you're gonna graph anything, whether it's a tangent or not, doesn't matter. If you're gonna graph anything, you wanna get rid of that. Not get rid of it, but factor it out. So factoring is division. So this is gonna be pi over 24. Okay. Now there's a lot going on in this problem. At pi over 24, something significant is happening. I'm not sure what I have to think about this. But that pi over 24 is significant. Remember, in a regular tangent, the origin, the beginning of everything, 0, is a dot, a 0. That is now shifted over to pi over 24. So there's a dot here. Now I know there's going to be an asymptote on each side. And I know those asymptotes are a period apart.
Would the dot that's on pi over 24 be 1 up?
It is going to be, yes. I'm trying to get my asymptotes in here. Yes, we've got a vertical shift. We'll get that in a minute. But the dot that's at the origin is now going to be here. Where are those asymptotes going to be? They're going to be a period apart. So the period is pi over 4. Which means, to figure out where to put my asymptotes, this whole thing is pi over 4. To figure out which is, by the way, 6/24. So to find out where to put the asymptotes, I'm gonna have to go forward 3/24 and backwards 3/24. Because if I go forward and backward 3, that will give me a total of 6. And that's what my total is. My period is 6. All right, so I'll move my dot up because now, well, it's going to be right side up. I mean, it's going to go like this, right? What does that 2 do?
The middle, in between the middle.
So what would be right here, right, should be at 1, or 1 up, should be 1 up. But now it's gonna be at 2 up. And this one, which is right here, should be 1 down, but now it's gonna be 2 down. And then I can,
Is that dot right there, is that a negative pi over 24?
no, it's in between here.
Okay.
Because the midpoint of 1 and -2 is not 1. So it's in between here, it's right here. Something 48. Yeah, negative. You don't have to label it.
Probably
No,
don't.
you have to label it here. Here.
We have to label the y-axis for that part. What about for that one?
On like a quiz or something, would you want us to put points at like where it's halfway? You know, like what's the
Oh, label them? No, I don't think that's
But
necessary.
do you want us to like make a point there?
Yes, you're gonna make a point. This point, yes, you're gonna make that point.
Okay.
But you don't have to worry about not labeling those. But that's how you know that whether your curve, sometimes these things look like this,
Yeah, yeah.
right? All right, so here is what, we're gonna stop there, but here's what you need to do. I have given you another review. There is another review in your notes packet, review 3/8 to 312, which we haven't done. And we haven't finished this review yet, although we're getting closer. So between now and Monday, you need to take a look at all that review stuff. I'm not saying you have to do it all. I'm saying I'm not gonna do it all either, not gonna have time.